Hello and welcome, good people. So in today's video, we will be practicing questions on Euclidean geometry, particularly similarity and proportionality questions. So here we are given that in the diagram, E and F are points on AC and AB respectively, such that AE over EC is equals to 3 over 2 and AF over FB is equals to 2 over 5. So when you're given information like this, what do you do with it? Right? So you always need to take the information that is given to you, indicated on the diagram, right? So on the line AC, right, we are given that AE over EC is 3 over 2. So I can say that AE is 3 parts of the line and EC is 2 parts of the line. So therefore, I can write this as this: 3A, call one part A, then EC, call one part A as well. So it will be 2 parts, 2A, right? Then also do the same thing with AF over FB. We are given that this is 2 parts. I can call a part B because we are on a different line now. Call this 2B and call that 5B. So that was given to us like that. Yeah? We took the information on the on the statement and showed it on the diagram. That's the first thing you need to do. You would see that in your final paper, they will give you a diagram on the question paper and a diagram on your answer sheet. The diagram on the answer sheet is for you to put in information on there. The markers would also take a look at your diagram and see your analysis, right? So they would also be able to see that this is how we named our ratios, right? So we are also given that FD is parallel to GC, right? For the fact that we have parallel lines in triangles, we can therefore take out proportionalities, right? So by taking a look at this one, this triangle here, we can see that this over that is equals to this over that, right? So let's indicate it. So AF over FG is also equals to AE over EC. Now it's also equals to what? 2 over 3 or 3 over 2, right? Wait, I flipped. Let's write it properly the way it was given to us. AF over FG is equals to AE over EC, which is also 3 over 2, right? And reason here would be prop theorem. I'm not even taking a look at the question. I'm just analyzing my diagram, right? That would be prop theorem. So if this over that is 3 over 2, I can call this one here, guess, I can call it 3C, right? I can call this 3C, call this one 2C, right? I'm using a different line for a, I'm using different letters for different ratios, right? So for the ratio AF over FG, I used C, and for the ratio AF over FB, I used the letters B, right? So always start where you see same letters, different letters on the same line, right? So this line, you can see it has 2 letters. We have 2B and 3C. So find the ratio, the relationship between B and C. So I can say that, okay, 3B is equals to 2B is equals to 3C, right? Divide both sides by 2. I can already see that, okay, B is equals to 3 over 2C. We would need this at some point, I'm telling you, right? Notice I haven't started answering the questions, but I'm analyzing the diagram, right? Putting information on the diagram. So now let's take a look at this one triangle here and apply proportionality theorem to it, right? So we can see that, okay, okay, I can see that FG over GB, or we can go this way, BG over GF is equals to BC over CD, right? This is because of prop theorem, right? Prop theorem, proportionality theorem, right? So now let's take a look at the question. The question is say calculate BC over CD giving reasons. Okay, I think we've already started the journey of answering this question. BC over CD is equals to BG over GF. Let's try and find the value of BG over GF. All right, on BG, right, we have nothing, and on GF we have 3C. Okay, but then look at this one. FB is equals to 5C, and remember FB is going to be equals to this part plus that part. So the remaining part here, this one, I can write it as 5B minus 3C, right? I can write as 2C here, 5B minus 2C, right? The entire length is 5B. This part is 2C. So the remaining part would be the entire length minus this part, right? So now let's put this and say BC over CD would be equals to how much? BG, right? Which is 5B minus 2C over CD. Sorry, not CD, over GF, right? Over GF, which is 2C, right? Remember, I told you that you would need at some point this relationship between B and C. So where I see B, I can substitute it with 3 over 2C. So this would be equals to 5 into 3 over 2C minus 2C over 2C, right? So at the top, I can already see a common factor of C. I can take it out. So I would have C into 5 multiplied by 3 over 2. That's 15 over 2 minus 2 all over 2C. The C would cancel that C. Then I would be left with 15 over 2 minus 2 all over 2. Put that in my calculator. (15 over 2 minus 2 all over 2). That's 11 over 4, right? So this is 11 over 4, right? I hope this makes sense, né, guys? So let's move on to the next question. Please feel free to pause the video and answer the question on your own. So here we are given that AC is parallel to that. Yeah? So because of this, we can take out a lot of ratios that are equal, right? But we need to be systemic in terms of answering the question. So let's take a look at the question. They say we should prove that BC over YZ is equals to DA over DX. All right, so DA over DX here is DA over DX, right? So what we can do is go try find other ratios that are equals to this one and find other ratios that are equals to this one, right? So I can already see that, okay, in this triangle here, I can apply proportionality theorem, right? So if that long line divided by this short line are equal, they're going to be equals to, sorry, this long line divided by that short line. So basically, I can say that dx, right? Or yeah, dx, or all right, let's go this route. Okay, dA over dx. Let's go dA over dx, right? So the short line over the long line, right, would also be equals to the short line over the long line, all right? So which is going to be dB over dy, right? All right. So now we can see that, okay, dA over dx is equals to this, right? Our reason is prop theorem. Yeah. Now let's try and prove that dB over dy is equals to this BC over x over yz. So let's try and prove that BC over yz is equals to dB over dy. We can use similarity to try and prove this, right? We can use similarity to try and prove this. So let's try and locate triangles that we're going to use to prove that. You can see that, okay, BCD, right? So going this way, the letters BCD, right? Is BCD a triangle? So BCD is a triangle. So triangle BCD is one of them that we're gonna use. Is YZD a triangle? So as you can see, YZD is a triangle, right? So also this triangle YZD is a triangle. So if I prove that this triangle and that triangle are similar, then I can take this ratio out. Yeah. So what I love to do is just name the angles in the two triangles. So in triangle BCD, let's name the angles that are there. So we see let's call this one D1 and call that one D2, right? So you can see that there's D1 in this triangle, and here we can call this angle B1. There's also B1 in that triangle, and there's also C1 in the triangle, right? So angle C1, right? Remember, we are showing this on our diagram on our answer sheet. So the marker would actually see, right, that we named it B1 and like named it like that. So let's list the angles that are in triangle YZD, right? So triangle YZD, all right, let's triangle YZD. Let's name the angles. The angles I can see, okay, call this one Y1, I can see Y1, I can see angle Z, I can see D1 again, right? So I would try to match angles that are equal, right? So I can already see that, okay, D1 and D1 is common. I'm gonna use a solid line. So let's try match other angles that are equal. I can already see that this one would be equals to that one. So B1 and Y1. So B1 and Y1 are equal. Then the remaining two would also be equal. So C1 and Z would be equal as well. So for the third one, I can use dotted lines like that. So how I'm going to name my triangle, I'm going to use the angles that are equal to name my triangles. So I'm going to name them properly now because of this is not proper naming, right? Because of when I name it, the angles need to correspond. So I can call this one triangle DBC, right? And the other one I can call it triangle. So the angle D in this triangle is also equals to angle D in the other one. So I can also call this one D, start with D. So angle B in this triangle is equals to Y. So the following letter here would be Y. And angle C is equals to Z. So the following angle here would be Z, the following letter, right? So if I prove that these triangles are similar, which I've already done if you think about it. So I'm gonna go like this, right? Now this would be my final answer, right? Triangle DBC and triangle DYZ. I'm gonna go D1 is equals to D1 because this is a common angle, right? Then I'm gonna go B1 is equals to Y1 because of their corresponding angles, right? Corresponding angles, and I'm gonna mention the parallel lines AC parallel to XZ. Yeah? Then the third angles are also equal. C1 is equals to angle Z. This is sum of angles in a triangle, right? So therefore, because of the three angles are equal, therefore triangle DBC is similar to triangle DYZ. Then once I've proved that the triangles are similar, then I can take out equal ratio. So I can remove this, right? Because this was just part of the process of helping me answer the question. Right? I can take out ratios that are equal from here, right? So look, the first two letters of this triangle divided by the first two letters are equal to the last two letters divided by the last two letters. So I can go dB over dy is equals to bc over yz, and also take the first and the last letter in this triangle divided by the first and the last letter in that triangle is equals to dc over dz. Yeah? So remember what we were trying to prove. I wiped it out. We were trying to prove that dB over dy is equals to BC over BZ, right? We are trying to prove that BC over YZ is equals to DB over DY. So can we see it here? DB over DY BC over YZ. Here it is, we proved it, right? So now, if you look at it, yeah, we first proved that dA over dx is equals to dB over dy, right? This, here it is there. So let me use a pink color for it. So this is here, and it's also here, right? So it means that these two ratios, they would also be equal because they are both equal to this ratio that I'm taking here. So I can therefore say dA over dx would be equals to BC over YZ because they are both equal to they are both equals to they are both equals to the other ratio, right? So this is how you'd prove it, guys. Simple and straightforward. Yeah, 5 marks. So let's do another one, right? So this one is very interesting, guys. Please feel free to pause the video and attempt it on your own. All right, so let's get to it. They say that in the figure, D is a point on BC. BD is 6 centimeters. All right, so let's go indicate that on our diagram. BD is 6 centimeters, 6 centimeters. DC is 9. So this whole length here is 9 centimeters, right? T and E are points on AC and DC respectively, such that, so now here's the important part, right? TE is parallel to AD, right? So here we are given parallel lines. TE and AD are parallel, so we will be able to take out equal ratios, right, or proportional ratios. We are also given a ratio here. AT divided by TC is 2 divided by 1. So use our method of using letters, right? So AT, I can call it 2A. So AT, that's 2A. Then TC, I can call it A, right? A single part of the line. So now, before even answering the questions, I can find ratios that are equal, right? So as you can see, AT over TC would be equals to DE over EC, so which will also be 2 over 1. So this one, I can call it 2B and call this one B like that. Try find more ratios that are equal. You can also see that this ratio, this divided by that is equals to this divided by that as well, right? So we can just write it down. Say that BD over DE is equals to BF over FT, right? So remember, we can always start where we see two things, right? So here I can see that, okay, this entire length is 9, and here is 3B as well. So I can say that 3B is equals to 9. So this would help me find the value of B, right? So, okay, I think we've put in enough information, then we can start answering the questions. So 20.1, show that D is the midpoint of BE. So showing that D is a midpoint simply means that if D is the midpoint of this line, it means that this part will be equals to that part. They want us to show that DE is equals to 6. Right. So remember, I told you that we can find the value of B by using this 9, because we know that, okay, 3B is equals to 9. So B would be 9 over 3, which would be 3. So therefore, DE, as you can see, it's equals to 2B. So it will be 2 into 3, which is 6 centimeters. Therefore, D is midpoint of BE, right? Because DE would be equals to BD, right? They would both be equals to 6 centimeters, right? So now let's move on to the next question, 20.2. So they are, sorry about that. They are giving us that FD is 2 centimeters. So here we are given that this is 2 centimeters. So now we just proved that here is, I'm sorry about that. We just proved that here is 6 centimeters, basically being equals to that, right? So now look, we have that in this triangle here. This is a midpoint, right? This is a midpoint. This line is parallel to that line. How? Now, this is midpoint theorem, guys. They want us to find the value of TE. So TE would be equals to what? 2 times, right? Remember, the midpoint theorem says that if this is a midpoint, and the lines are, sorry, this is this, okay, this side and that side are equal, making that a midpoint, and also we have parallel lines here. It will simply mean that, okay, also this side and that side are equal, and also this length is gonna be half that one. So TE basically is gonna be 2 times E, is it F, 2 times FD, right? 2 times FD, which is going to be 2 times 2, which is 2 times 2, which is 4 centimeters, right? Now let's move on to 20.3. They say we should calculate the area of triangle ABC over the area of triangle ABD. So this is a very interesting one, right? There are 2 approaches to it. Yeah? Each, can you see, we have 2 ratios that we need to find, right? So for the first one, we're going to use a particular method, and for the second one, we're also going to use a particular method, right? So which method are we going to use for each? So if you have, so the triangles that we want to find the ratio between their areas, if we have a common angle, right, in those triangles, then we're going to use the area rule, right? That one that has sine theta. If they have a common perpendicular height, meaning they come from a common vertex, but they don't necessarily have a common angle, then we're going to use the area equals to half base times perpendicular height formula. So let's see, let's indicate the triangles ADC. So triangle A is ADC, ADC is here. So this triangle, let me try do it a little bit straight. ADC, and the other one is ABD. So ABD. So this blue triangles, so they don't have a common angle, right? So this one does not share an angle with this one, but they all come from a common vertex. As you can see, the vertex here, they all have a common vertex there, right? So they would both have a common perpendicular height. So if I were to draw the perpendicular height, it would be like this, right? So call it H. So this is an obtuse angle triangle. As you can see, if I want to find its perpendicular height, I would expand its base, then its perpendicular height would be this one, right? Same thing for this one. This one is an acute angle triangle, so its base would be this one, and its perpendicular height would just be a line that comes perpendicular to that one. So as you can see, both of these triangles, they have a common perpendicular height H, right? So now let's use the formula area equals to half base times perpendicular height on each of them. So we're going to say area, that's too big. So area of triangle ADC over area of triangle ABD. So this one would be half the base of this one multiplied by its perpendicular height. What is the base of triangle ADC? The base is DC, so this is going to be half DC multiplied by the perpendicular height, which is H, over half, this one, its base, triangle ABC, is it ABC? ABD, sorry, ABD, right? So triangle ABD, its base is BD, right? And its perpendicular height is H. So this is BD multiplied by H. So as you can see, the H will cancel the H, the half will cancel the half. So basically this is DC over BD, right? So what is the value of BC, of DC? So DC, as you can see, it's 9 centimeters. Then BD is 6. So this would be 9 over 6, right? Then we solved the problem, right? Now let's move on to 20.4 using a similar approach, right? We're going to use a similar approach. So let me wipe these things here. so that we can indicate our new triangles that we are dealing with now. So we are dealing with triangle TEC and triangle ABC. ABC, right? So now these triangles TEC and ABC, they have a common angle here at C. So let's indicate the common angle there with red. Yeah? They have a common angle. So when they have a common angle, we're gonna use, okay, let me wipe some of the things here just to create some space. So when they have a common angle, we're gonna use area rule, the one that says area equals to half AB multiplied by the sine of C, right? So just to remind you of the area rule, it says that if you have a triangle like this, and this is A, B, C, right? So if you were to name the sides using their corresponding angle, this side here would be small letter B, this side here would be small letter C, and this side here would be small letter A. So if I'm using the angle A, for example, to calculate the area, right? So I'm gonna use the other sides C and B. You get it, no? So therefore here the area would be half B multiplied by C, the sine of angle A. Same thing, if I'm using this angle, then the sides that I'm using are gonna be B and A. So just to show you that, okay, the angle needs to be included between the sides that I'm using. Yeah? So I was just reminding you of that one. So let's make use of this. So here I have area of TEC over area of ABC, right? So area of TEC, now let's take a look at triangle TEC, right? So if I'm using the angle C, I'm gonna use the sides, this one and that one, right? So if I'm using this angle, the sides must be included. So I'm gonna say area is half the small letter A multiplied by B, the angle sine angle C, over now the bigger triangle, right? So I'm still using this small angle here, C. So I'm gonna use the corresponding sides or the sides that are gonna include this angle. So it's this whole side and this whole one, right? So this is basically 1 over 2, 2A plus A, that's 3A, multiplied by the side here, this one is 9, the length of this one is 9, and the length of this one is 6. So basically 9 plus 6. 9 plus 6. All right. 9 plus 6, that's 15, right? Multiplied by 15, right? But then remember, at some point we found that the value of B is 3, right? Remember that B is 3, right? So I can remove this B here and write it as 3. Then sine of angle C. So sine C cancel, A cancels A, right? 1 over 2 cancels 1 over 2. Then I am left with, at the top I'm left with 3, at the bottom I'm left with 3 times 15. All right, the 3's looks like they're gonna also cancel each other out. 3 cancels out 3, and I'm left with 1 over 15. I hope that makes sense, né, guys? Now let's move on to the next question. Right, another interesting one. You can pause the video and solve it on your own. So here we are given that uz divided by yz is 4 over 7. Same method, indicate the letters, indicate the ratios using letters. So where is uz? uz is here, and that's kind of called it 4a. Then yz is 7a, so that basically is 7a. But look, this entire length is made up of this part and that part. So if this part is 4a, this remaining one would be 3a. So I can call this one 3a, right? Then the whole thing would be 7a. So I don't think there's a need of showing this 7a. So I can just say 4a here and 3a there, right? They also gave us that v3 is equals to v4, right? So this and that are equal, right? So we are required to prove that yv over vw is equals to xv over vz. So the approach is go and look for ratios that are equals to this one and go look for other ratios that are equals to that one. So let's use proportionality theorem here. Take out the ratios that are equal. Let's see. I can see that this triangle here, in this triangle, right, I can already see that this divided by that would be equal to that over that. So I can already say that, okay, xv over vz is equals to yu over uz, right? Now, can I prove that yu over uz is equals to yv over vw? Yes, it is. Take a look at this one. Take a look at this. Take a look at that one, right? So let me change the color. Yu over uz would be equals to yv over vw. So both reasons here are prop theorem, and also here prop theorem, right? So now look, this one is okay. Wait, let's see which one is common. This one and that one, it's the same thing, right? So therefore this would be equals to that. Xv over vz would be equals to yv over vw, right? So we've proved the 3 marks, right? So now let's move on to 27.2. So now they want the ratio of area of xvy over area of wvz. All right, so let me just wipe these colors here so that everything can be clear now. So let's indicate the triangles that we are dealing with, right? So we are dealing with this triangle x, xv, y. So it's this one. And the other triangle is w, v, z. Right? So these are the triangles that we are dealing with. So if I'm looking at these triangles, I don't see a common angle and also don't see a common vertex. But then a beautiful thing is that this angle is equals to that angle, right? So these two angles, they are common. It's more of like they're equal, right? So if I have equal angles or in common angles, it's the same thing, right? So I can use which one? I can use the area rule, right? I can use the area rule. So I can use the area rule. But then before that, let's go find other proportions that are equal, right? So as you can see here, if this one is 3a, this one is 4a, right? This one can be, remember, same ratio. So this would be 3b and this would be 4b, right? Looking for other proportions, we have this one as well. All right, we have this one as well, right? So 4a would correspond with that one, so I can call it this one 4c, and 3b would correspond with that one, I can call that one 3c. right? So just to like find the other sides using letters. So now I can use the area rule here. Can use the area rule in this triangle and use the area rule in the triangle, right? So I'm gonna use these angles, right, as my angles. So for the first one, area of triangle XVY, this would over area of triangle WVZ. This would be equals to XVY. So this I'm using this as my angle, right? So I'm gonna use this sides 3B and 3C, right? So it's 3B, so half 3B multiplied by 3C, the sine of angle V2, right? Over, right? Same thing, half on this triangle now. I'm still using this angle V5, but I'm gonna use the sides 4B and 4C, right? So half 4B multiplied by 4C, then the angle is V5 sine V5, right? So half would cancel half, the B's would cancel, the C's would cancel. Then at the top, I'm left with 3 into 3 multiplied by sine V2. And at the bottom, I'm left with 4 multiplied by 4 sine V5. But yeah, V2 and V5 are equal. These are vertically opposite angles, right? Vertically opposite angles, right? As you can see them, they're vertically opposite. So they can also cancel each other out. So sine V5 would cancel sine V2 because those things would be equal, right? Then I'm left with 9 at the top. 3 times 3 is 9. And at the bottom, I'm left with 4 times 4, which is 16, right? So this is how you answer these questions, guys. Thank you for watching this video. Comment on the comment section.